Okay, so we're doing this now. I'm going to start you with a function. I think I do one linear here and then one quadratic below. And we're going to review a whole bunch of stuff from chapter 1. So we're going to talk about domain, range, intercepts, x-intercept, y-intercept, right? Positive, negative intervals, which I think we haven't talked about since chapter 1, increasing and decreasing. This is good review, right? So we're just going to go review it. So I think that we're just pretty much just talking about all this stuff. Nothing new to do with that. We're just using those words again. Okay, so that's a good review there. Then we're going to use my answer from A to sketch the graph. Honestly, when you sketch it, you're going to already know how to sketch it from what I just taught you on the page before. So let's just go ahead and go right into this question. I'm going to rewrite this. So I'm going to rewrite it like this. Negative x plus 2, so that I can pull out, I know that the m is negative 1 and the b is 2. You don't have to rewrite it, but just that's how I would graph it. Right, so I'll graph it like that. So I'm going to do that first. I'm going to graph it, and then I'm going to do the domain and range from my graph, right? Why not? Because if I'm going to graph it anyway. So I got 2, and then we're going to do slope is negative 1, so down 1, cross 1, down 1, cross 1, and I'll just keep going like that. Always go as far as you can, right? Again, you know why, because we have to intersect and stuff. So let's go as far as we can, backwards and forwards, right? We're trying to do enough dots, follow the pattern back and forth, and try to get a nice line all the way through there. Okay, as long as possible, arrows, all that jazz. Okay, so follow the pattern. All right, so when I do the domain and range, I can do it from the graph. If they're asking me to graph, I can do it from the graph. You can also do it algebraically, but I mean, we already have the graph to find the intercepts and stuff, so I'll show you both. But let's just go ahead. So we've got A. So for A, domain and range. So this is going to be, x is going to be from negative infinity to infinity, and y is going to be from negative infinity to infinity. So domain and range. Intercepts, I'll do x-intercept. So x-intercept is going to be, and I can read it from the graph, right? So the x-intercept is going to be 2, right? So 2? Yes?
Wouldn't the range be from infinity to negative infinity?
Negative infinity to infinity?
If it goes from infinity, because on the left side of the graph it's going up.
No. When you do the range, you're doing the whole thing. It's not where the arrow. Remember I said cover the arrow? So you're just talking about the graph. Where is it? It's going to go forever and ever up and down, but it's not the direction that the arrow, so don't follow the direction. So you're not telling it where to head. You're just saying that this graph keeps going this way, right? So we're going to say always from negative. And you always want the domain and range to go from the negative to the positive, yeah. Right, when we talk about it. So the x-intercept is 2. You can just do it from the graph. If you want to do it algebraically, you could as well. So you can say, okay, so from the x-intercept is going to be when y equals 0. So you go 0 equals 2 minus x, x equals 2. So you can do or, I'll say or algebraically. Okay, it's up to you. If you have a graph, you can read from the graph. If you want to do it algebraically, you can. Right, so set it equal to 0 and solve. Up to you. For these ones here, I'm just looking for the x-intercept, y-intercept. So the y-intercept is going to be, again, when x equals 0, so you can solve it, or I can just look at my graph and I can see my y-intercept is at 2. Okay, so algebraically or from the graph. It's up to you, and I've got that ready answer. Okay. What else do we want? Positive, negative intervals. So now I want positive, negative intervals. So positive, okay, and negative. Okay, and again, we're going over all these words. We haven't done this, I think, since chapter 1, I believe. So positive is where the y values are positive. So the y values are positive over here, right, all the way there. So it's from this value and anything to the left. So it's positive this whole side of the graph. So you're going to say from x is going to go from negative infinity to 2. Round on the 2, right? Because it's neither positive nor negative at the 2. Okay, 0 is neither positive nor negative, so we just ignore. Okay, so it's positive that side. It's negative, the y values are negative anywhere down there, so you're going to say from 2 to infinity. So positive and negative intervals. And again, we're not including the 2 because at 2, y value is 0, so it's not positive or negative. So we leave that round. Okay. Increasing and decreasing. So increasing, again, I used to say cover up the arrows, right? So don't look at the arrows. Where is this graph heading up? The y values. We're always talking y values, and you're answering me with the x values. So I'm asking you, where are the y values positive? Y values, where are the y values positive? And you answer me when x is here. And I'm saying, where are the y values negative? The y values are negative here, and you say when x is here. Remember, so I'm asking y values, and you're answering me x. Then I'm asking for this next one, when is it increasing and decreasing? Increasing in the y values. When are the y values heading up to the right? So this means, increase means the y values are heading up to the right. Don't follow the arrows. Do not follow the arrows. Right? You're like, up to the right, no. When I'm reading the graph, when you read these words, what did we automatically do? We read the words from left to right, correct? Okay, I need you to read this graph from left to right. When are the y values increasing from left to right? They don't say left to right, they assume you know. When you're reading this graph, when am I walking this graph left to right? Ever? Never. Left to right? Downwards, the whole time downwards. So I'm always walking, so I'm pretending, oh, I'm walking, here I am walking. I'm walking the graph and I'm falling down the whole way, which means my y values are heading down the whole way. Does that make sense? Don't follow the arrows. People go, it's heading up. No. Left to right. We have to put the arrows, so don't not put the arrows. You have to put them there. But when I'm walking the graph, right, from left to right, I'm heading y value down the whole way. Does that make sense? So sloping, slope, down. Now you're used to that from grade 9. Sloping down, slope down. Okay, so then that means it is increasing, none. There are no intervals where it's increasing. For decreasing, okay, again, the whole graph is sloping down. The whole graph is, so you're going to say from x, negative infinity to infinity. So I'm asking you the y value, you're answering me the x value. Does that make sense? I'm trying to, again, we did this way back in chapter 1. It's been a little while. Okay, did I finish everything? So domain, range, intercepts, intervals, increase, okay, we got all of A done. Use your answer from part A to sketch it. So everything we have here, we already know how to sketch it. So we already have the x-intercept right here. So I know that that's going to be a vertical asymptote. So remember, there's 4 steps. Just double check. You're doing asymptote, asymptote. So 2 of them are asymptote. This is vertical asymptote. Draw it, label it. Horizontal asymptote. So here, is there one? Yes. Anything linear and quadratic will automatically have a horizontal asymptote. So asymptote, asymptote. Draw it, label it. Right? That's 2 of my steps. Yes? Yes. Yeah, because your number gets bigger, and what's happening? It's getting smaller, closer to 0. Right? So 1 over 100, 1 over 1,000, 1 over 1,000,000 gets closer to 0. Yes, always be at 0. Okay? Then invariant point. Remember, there's 4 steps. 2 of them are asymptotes. Then it's invariant point, and then it's max min. One of the steps I don't have to do. Max min, no max min, so I can skip that. So I need invariant points. So wherever y is 1 and negative 1. When it's 1, put a dot. When it's negative 1, put a dot. There you go. And now draw the rest. So those 4 steps are how I begin my graph. Then the rest of those words were how I draw the graph. So as it increases away from the x-axis, I'm heading towards the x-axis. As it heads towards the x-axis, I'm heading away from the x-axis. Again, away from the x-axis means towards, and then this way, same thing. All done. Right? The graphing of it's actually fast. Oh, I didn't do the invariant points. Sketch the graph, find the intersection point. So for B, I want to find the intersection points. So let's answer B. Intersection points. My intersection points are going to be at, and if you can read it from the graph, it was an exact point, right? So that was going to be 1, 1, and 3, -1. Yeah, if you can read it from the graph, go ahead and read it from the graph. The next one, I'll give you one that doesn't, right? So if you're like, what does it look like if I can't? Okay, I'll pause this.